All right, so 11.3, the first part of it, it's really completely two separate sections, but they put it together in the book. We're going to talk about areas of circles and sectors. So area of a circle, formula for circumference, you should know already, 2 pi r. That's easily confused with the area formula because it uses the exact same symbols, pi r, but instead r is squared instead of multiplying by 2. These get mixed up more often than any other formula. You have to make sure you know which one you're using and when. And a sector is like a slice of a pie. Sector is a region bounded by 2 radius of a circle and the arc intercepted by those radius. So it's a slice of a pie. If you have a pie, probably, French silk because that's the best. You cut the slice of French silk pie. That slice, how big that slice is your sector. And sector area, how big the slice is a very similar formula to finding the arc length. Still degrees over 360. But instead of being arc length over circumference, instead of circumference we're using area, instead of arc length we're using sector area. So this formula is set up the exact same way as what we just did with arc length, but now we're using it for area. So example 1, we start out with a circumference of 18 pi. The question says find the area. So if the circumference is 18 pi, that means that's equal to 2 pi r. Since that's 2 pi r, let's cross out the pi's. Divide by 2, r is 9. So when I go to find the area of this, I'm going to plug in 9, but this time I'm going to square it. 9 squared, 81 pi. So second question, what is the area of 1/3 of that circle? Well, let's divide by 3, 27 pi. Now, how's that important? 1/3 of the circle is a 120 degree sector. 120 over 360, that simplifies to 1/3. And then that 27 pi would be the sector area, and then the 81 pi would be the entire area. So let's find the area of the sector below. Let's actually try that formula. So we have degrees over 360 equals sector area, we don't know, over 2 pi, oops, I mixed up my formulas. Pi r squared, 6 squared. So 45 over 360, if you want to simplify that you can. I've got a calculator in front of me so I'm not going to. 6 squared is 36. So 36 times 45, you're going to get 1,620 with a pi at the end equals 360x. When you cross multiply, I'm going to divide both sides by 360. And when I take 1,620 and I divide by 360, I get 4.5. 4.5 pi. Alright, next problem. Area of a circle is 49 square units. What's the circumference? So we're going backwards from the one that we did earlier. We know the area this time is 49 pi, and it's equal to pi r squared. Let's cancel out the pi's. So I get 49 equals r squared. You got to take the square root of both sides. You get r is 7. Now that r is 7, let's plug it into circumference. And 2 times 7, 14. So we got a 20-inch pizza, meaning the diameter is 20 inches. If he ate 40 degrees of the whole pizza, how many square inches did he eat to the nearest tenth of a pi? This is telling me I need to answer with the term pi in there, and I want to round the rest to the tenth. So 20-inch pizza means r is 10. The degrees, 40 over 360, equals the area we're looking for over pi r squared. 10 squared is 100 times 40, 4,000. 4,000 pi equals 360x. So I'm going to take 4,000, I'm going to divide by 360. I get 11.111 repeating. So we're going to go 11.1 pi Problem number 3, this is review. Let's find the area of the trapezoid. If I draw this height in and split this up, the top's 14, so the bottom's 14. 19 minus 14 makes this 5. 5, 12, 13 because that's a right triangle triple. So the area of a trapezoid was height times base 1 plus base 2 over 2. So the area is 12 times 14 plus 19 over 2. 14 plus 19 divided by 2 times the height, which is 12, and we get that the area is 198. Now we've got a circle inside of a square. The square is the biggest shape, so I want to take the area of the square and I want to subtract the area of the circle. The reason I want to subtract is that's not shaded. If I didn't have the circle there, it would just be a square, and that's 4 squared minus, let's take away the part that's not shaded, pi r squared, and if all the way across is 4, the radius is 2. 4 squared is 16, 2 squared is 4, 16 minus 4 pi. And I'm going to leave it like that because this one has a pi and the 16 does not. Similar idea here. The only difference is there's 4 circles. So area of a square again minus 4 circles. So the square is 24 squared minus 4 times pi. I need the radius of each circle. So if the entire length across is 24, that means the diameter of each one of these circles is 12. If the diameter of each one of these circles is 12, that means the radius is 6. So 6 squared is 36. Let's multiply that by 4. This is 144 pi. And 24 squared gets you 576.